In this lesson, we will learn how to test for the presence of hydrogen, oxygen, carbon dioxide, ammonia, and chlorine. We test for gases in the laboratory because it is nearly impossible to determine the identity of a gas just by its appearance. As an example, hydrogen, oxygen, and carbon dioxide are all colorless and odorless. How would we be able to determine which is which? To test for hydrogen, place a lit splint at the mouth of the reaction vessel. You should hear a very distinctive squeaky pop, which confirms its presence. This is due to the combustion reaction of hydrogen in the presence of oxygen, creating water as the only product. To test for oxygen, place a glowing splint at the mouth of the reaction vessel. Keep in mind that the splint should be glowing, not lit. A glowing splint relights in the presence of oxygen. Why does hydrogen burn with a squeaky pop? Why does oxygen relight the glowing splint? Hint: recall some properties of hydrogen and oxygen. Please pause the lesson to think about this and resume once you are done. Hydrogen is highly flammable, and the pop sound that you hear is actually a mini explosion. The glowing splint relights in the presence of oxygen as there is a higher concentration of oxygen in the reaction vessel than compared with air, which is only 21% oxygen. Carbon dioxide will extinguish a lit splint, but the same occurs in the presence of ammonia. A more accurate test is to bubble carbon dioxide through lime water, which is an aqueous solution of calcium hydroxide, also known as slaked lime. Lime water turns milky in the presence of carbon dioxide due to the formation of calcium carbonate. Ammonia extinguishes a lit splint and turns damp red litmus paper blue. In the presence of concentrated hydrochloric acid, a white smoke will form. This is ammonium chloride and confirms the presence of ammonia. Chlorine turns damp blue litmus paper red and eventually bleaches it to white. In conclusion, hydrogen burns with a squeaky pop, oxygen relights a glowing splint, and carbon dioxide turns lime water milky. Ammonia turns damp red litmus paper blue and forms a white smoke of ammonium chloride in the presence of concentrated hydrochloric acid. Chlorine turns damp blue litmus paper red and continues to bleach it to white.